I was writing the question. Right. So just let me know once you're able to see the screen, and meanwhile I'll just write the question.
Yes, I can see the question.
Okay. Also, we'll start the last chapter today, okay? Because we are almost done with this. So we'll start that as well. Okay. So this is the first part. Right. So the example is a stone is dropped from rest from the top of a high building. So are you studying physics as well?
Yes,
Okay, so you would have understood this, right? From rest
yes.
means that initially the stone was with zero velocity, obviously, and then once um, they have dropped it from the high building, obviously, then it will have
It
speed.
increases.
Yes, okay. So the speed V meter per second after t seconds is given by differential equation test. Okay, now forget about what the concept is. Even if you're not studying physics, still we should be able to understand it, because in this question they have given us the differential equation. We haven't been asked to make the differential equation, right? So once you have your differential equation, you can easily find an expression for v in terms of t, right? Can we do that?
Yes, we can.
Okay, perfect. So the differential equation is dv by dt equals 10 minus 0.5v. In order to find an expression in terms of v, means we need to find v equals something. And this basically would be done by doing what? By integrating the expression.
Yes.
But if we do it directly, if we take dt to that side, we know
Take the
that,
reciprocal first.
yes. So dt by dv equals 1 over 10 minus 0.5v, and now I can just take this to that side. So I will have dt equals 1 over 10 minus 0.5v dv. Okay, once I have this, I have
Then you
to,
can integrate it.
yes, I can integrate both sides. So I'll do it on this side. I'm going to get t equals, and what is the integral of this?
Ln 10 minus 0.5v.
What? Say it again.
Ln 10 minus 0.5v.
Yeah, why are you laughing? Yes, you are right. Okay, so you're saying ln ln 10 minus 0.5v. Okay, very good. But you need to focus on one thing. What? We need the derivative.
Differentiate that as well. 0.5, negative
Yes,
0.5.
yes, yes. Okay, we'll do that. We'll do that. But what is the thing? the derivative of denominator should be in numerator, right? So what is the derivative of denominator? It is minus
0.5.
0.5. Okay, so we don't have that in numerator. Okay, so yes, it would be this, but with some changes over here. What we need to have this, so I will multiply this and divide as well, just so it is mathematically correct, right? And now
Yes.
I can say minus 1 by 0.5, right?
Yes.
Okay, right. And this is going to give us, this can be written as t equals minus 2 ln 10 minus 0.5 v. Okay, yes. And you were saying that we need to divide the derivative. Like we had to do this, okay? But you can think it this way or the other way, okay? Like your method was also correct that you divided by the derivative of the denominator, but you should think logically, okay? That why? If we had minus 0.5 in the numerator, we would not divide this, okay? You said this now that we'll be dividing the derivative of denominator.
Yes.
Okay, so what is the logic? Yes, in this case it is correct because we did not have the derivative in the numerator. Okay, we had to make the derivative in the numerator, and for that we had to write this as well. So yes, in this case it was correct. But if we had, but if since we are doing differentiation, so it's good that we recall these concepts as well. But if we had minus 0.5 already in the numerator, our answer would have been this only. Okay, then you don't divide it by the derivative of what you have in the brackets, right? Okay.
Okay. But then you would take negative 0.5 outside the integral sign, right? Because it's a constant,
No, no, no,
or
no, no,
no?
no, 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 no. You are right. We take constants out. Okay, no doubt. But in this case, it is that form f dash x over f of x integration dx. Okay, so what do?
Oh,
We do
okay.
ln
Yes.
f of x. Okay, so in this case, we are basically using this too. Okay, it is also part of the integrand. Okay, so I'll just remove all this. Okay, and now plus c, very good, because whenever we integrate, we get our constant. Okay, so Ranjani, should we stop or what should we do? Like, is this the answer? Is this the answer? No, it is not.
Find
Why?
an expression of V in terms of T.
Yes, very good. Okay,
Oh
v in terms
no.
of t. So we have t in terms of v. We need to change that. Okay, we can't work with that. So I'll take c
Yes.
to the left hand side and I will get t minus c. I will divide this minus 2, okay, in one step, just so we don't waste time. And we have ln 10 minus 0.5v. Okay, now how do I get rid of this ln? What should I do?
We're taking E on both sides.
Very good. So I will get e to the t minus c by minus 2 equals 10 minus 0.5b. Okay, now okay, I can just do it here. I'll do it here, okay? So what am I going to get? I got e to the t minus c by 2 equals 10 minus 0.5 V. I can take 10 to that side. So this would become minus 10 plus e to the t, and this is minus 2. Okay, we had minus 2. It's minus 2. Okay, because we had minus 2 here. So first I took c to the left hand side. So it became t minus c. Then this minus 2, which was being multiplied, I had to take it to left hand side. So we'll be dividing it. And once I have this, I need to take exponential function on both sides just to get rid of this ln. And finally, I got this. And now I need to take this 10 to the left hand side. So it is being added here. It would be subtracted there. This equals minus 0.5b. And this is t
We'll
minus c
take that down.
divided by minus 2. Okay.
Minus 0.5.
Yeah. And I will take that again. So this would become positive 10 because we have minus sign here. I'll take that minus e to the t minus c divided by minus 2 whole divided by 0.5 equals v. So have you understood this question?
Yes.
Everything, the simplification in every step?
Yes.
Okay. So we got v equals 10 minus e to the t minus c divided by minus 2 whole 0.5. Now we'll simplify it further, but in next step, okay, because it would be needed in that step. Okay, no questions from first question. Again, if we have differential equation, you can easily just solve differential equation to get an expression for this function in terms of this function. Okay, so this is what happens whenever you solve a differential equation, and this was their indirect way of asking you to solve the differential equation. Okay, so far it is clear. Okay, so I'll rub this and we'll talk about the second part. Okay, now I have B part, which says show that the speed approaches a limiting value. Okay, now we need to understand the question first. Okay, show that the speed, that is v, approaches a limiting value. By limiting value they mean a constant value, or maybe a fixed value, right? Or maybe a value that is not changing, right? So
Yeah.
let's look at the expression which we got, and then we'll figure this out, that what exactly they mean. So we have v equals 10 minus e to the t minus c by minus 2, and I can just divide it here and here separately, because I need to study my equation, and I would be able to do that in the best way only when I have it properly. So this would give me v equals 20 minus 2 e to the t minus c by minus 2. Okay.
Wait, how do you get 20?
Okay, so we have 0.5 in the denominator. 0.5 is 1 by 2, right? So 10 by 0.5 is 20.
Oh, okay. I got it. I got it.
Okay, now, all right, all right. Okay, now I need to simplify it further. V equals 20, and you know that what made me know that I need to simplify it further. 20 to e to the, I'll take this minus to the numerator, okay? Why? You'll understand that. So we will have c minus t by minus 2, right? Is this what I'm going to get?
Yes.
Okay. And obviously, if I've taken the minus to the numerator, I'll only have 2 here, not minus 2. Okay. All right. Now I have this. Now we have to show that the speed approaches a limiting value. Speed approaches a limiting value means that after um, good amount of time, there would be a point that finally the speed would approach a limiting value. Okay, so this finally is telling me that I need to think of t equals infinity. Okay, t equals a big value, that finally there would be a time when v would be fixed. Okay, now think about this. When t is infinity, okay, when t is big enough, can I write v equals 20 minus 2 e to the minus infinity divided by and only minus infinity? Because look, if t is minus infinity, c minus infinity would obviously be minus infinity, right? Because infinity is a big number. So if even if
Yes.
I'm adding a small number, still it would be infinity. And if I'm dividing by it by 2, still it would be infinity. Okay, right. So this is basically 20 minus 2 divided by e to the minus infinity, and sorry, plus infinity. Okay, because I had minus here, when I take it to denominator it becomes positive. Okay, and e to the infinity itself is infinity, right? Just like 2 to the infinity is infinity, like if I'm multiplying 2 infinite times, this expression would be infinity. So just like that, e to the infinity would also be infinity. Do you agree?
Yes.
Okay, I'll explain this again, just follow it for now. 20. Now I have 2 over infinity. What does this mean? That this whole thing would be 0, right? Whenever,
Divided by infinity is 0?
yes. Whenever you are dividing something by the world's biggest number, we assume that we get 0, okay? It would be 0, right? Because if we have 2 divided by this big number. Now, this is not infinity, but still we will get
0, 0, 0, 0.
0.0000002.
Yes.
Okay. So if it's, even if it is a bigger number, if it's infinity, so it would be approximately 0. So what are we getting? We are getting v equals 20. So what was the question? Show that the speed approaches a limiting value. Now, I'll tell you, in differential equations, the questions would be of a certain type. Okay, they can't play with the questions too much because it is a small topic. The only changes they can make is in these types of things. Okay, so here, since they are saying approaching, okay, approaches, show that the speed approaches a limiting value means that after a certain amount of time or at the very end of the period, it would reach a limiting value. For that, we need to think of t equals infinity. Okay, think of t equals infinity and then do your calculation. So we had this expression. Since t equals infinity, this whole thing would be minus infinity, right? And when we have something with minus in numerator, I take it to denominator and it becomes positive power. So now we have e to the positive infinity. And e to the infinity is basically infinity itself, right? So I
Yes.
can write down infinity directly, and anything divided by infinity would be 0. So we have 20. So 20 meters per second is the limiting value of speed. Like speed, as t increases, there would be a time when speed is fixed and it becomes 20 meters per second. Right? So have you understood this?
Can you please explain it again?
Yes, yes, I definitely can. Okay. Right. So what is the second part? Show that the speed approaches a limiting value. Okay. So forget about differential equations, forget about the method, just think about the statement. What do you understand by this statement? That as t increases, there would be a time when speed gets fixed or when speed gets constant, right? So we need to prove that. We need to prove that. Okay, and how do we prove that? This is what we had for V. We need to simplify it because we know that whenever we have such questions where we need to use this, we need to have a simplified version. Okay, because if I put infinity over here, I would never ever be able to understand that what is going to happen. I would never ever be able to say that this is 0 and this is still 20. Okay, I had to simplify it because I know that in such type of questions, I need to use t equals infinity. Why? Because of this word, that the speed approaches a limiting value, that after some time, as t increases, speed would be fixed. Okay. So in order
Yes.
to prove that, we will use t equals infinity. Okay. And where are we going to use t equals infinity? In the equation which we made. And what was the equation exactly? The equation was v, like after simplifying it, we got this. V equals 20 minus 2 e to the c minus t divided by 2. And if you remember, we had minus 2 in the denominator, and I took this minus to numerator because I knew that I had this thing in my mind that for limiting value, I need to find a constant value, a fixed speed, which would not be changing with change in time, right? I need to have such an expression which becomes fixed even if t is changing, right?
Yes.
Okay. So this is v equals 20 minus, okay, minus 2 e to the, I need to use t equals infinity. This would be minus infinity. This is 20 minus 2 e to the infinity. Now this whole thing would become 0 because of this logic. Whenever we have a big expression in denominator, the fraction becomes 0 and we have 20. Okay. So have you
Yes.
understood this question? Okay. So have you understood this question?
Yes.
Okay. Now just know that in this section, these types of questions are very common and they might ask such questions, but you don't have to worry about these. Okay. Things are not going to be that different. Every time, whenever you have such a statement that, after some time, you need to prove limiting value, right? This means that using your using your solution of differential equation, this was the solution, you will find a fixed value, right? And that fixed value would basically be this type of value which doesn't have t in it, right? Every time this expression would be becoming 0 by using t equals infinity. Okay.
Yes.
Have you understood this question now?
Yes, I have.
Are you sure?
Yes.
Okay. All right. Now we have, I'll rub all this and we have the last section. In fact, I'll clear all joints. Okay. So we have 8.3 separation of variables. Okay. Now, if you have dy by dx equals minus x y square, this type of a differential equation, how are you going to solve this equation? Again, you'll take reciprocal. Okay. Now, if you try solving it, first you'll think that we take dx to that side and you will get minus x y squared dx. Okay. But again, there's a problem. You have y square here and your dy is here. So you might think that we need to take reciprocal. So even if you take reciprocal, you will get dx by dy equals 1 by minus x y square. And now if you take dy there, you will have dx equals dy 1 by minus x y square. Now you have x here and dx here, okay? So the problem is not being solved by taking reciprocal. So we need to do something different. But you'll understand it, okay? Don't worry. Have you understood the problem?
Um, yes, no, no, I
No.
haven't.
Okay. All right. Look. So this is the differential equation which we want to solve. In order to solve any differential equation, we know that we need to separate,
Yes,
x with
implicit.
dx and y with dy. Okay. Yes, yes, you can say that we have x and y mixed, but it is not exactly implicit differentiation. Okay, because here the differentiation has been done for us, right?
Yes.
Okay. All right. So you are correct, but we need to think of a method that how can we solve it. Okay. So initially, one might think that we take dx to that side. If we take dx to that side, we get this, and we have y here and dy here. So we know that there's a problem, right? So in the old questions, whenever we were coming across such problems, we used to take reciprocal. Okay, so let's try doing here. We took reciprocal, dy by dx would become dx by dy, and the right hand side would become 1 by minus xy square, right?
Yes.
And now when I'm taking y to that side, I'm getting dx equals 1 over minus xy square dy. So again,
Yes.
I have
You can take
x here.
minus x to the other side.
Very good. Excellent. Very well done. Right. So things are this straightforward in this chapter. Very good. Okay. So we know, and we don't have to learn anything that, that you have to take reciprocal or stuff like that. No. You can play with your variables as long as your method is mathematically correct. You just have to take x with dx and y's with dy. And yes, if you're doing it in a way that is mathematically correct, then yes, that is correct. Okay, so let's do it. So I need to solve this. And how do I do that? I'll take dx to that side and I'll get dy equals minus x y square dx. And I can take y square to this side because I have dy here. So I will have dy 1 by y square equals minus x dx, right? Is it clear?
Yes.
Okay. And now I need to integrate both sides. Okay. So, yeah. Okay. So, what am I going to get on the left hand side and on the right hand side? It is a chance of revision for you. Yes.
Yes.
What?
Integral of y square is ln y square.
Okay. So, we have okay, minus x. Okay. So, you were saying that, okay, first let's just keep things simple. Let's just write it this way. Okay. Now you're saying that what okay. You're saying ln y square. Very good. Okay, it's okay. You are close. But look, for ln y square, what is the condition? We need to have f dash of x divided by f of x, right? For this type of a form, we get ln f of x. What is the derivative of y square? It is 2y. We don't have 2y in the numerator, right? So we cannot write the ln thing, okay? Have you understood this?
Yes.
Okay.
So
So
minus 2y to the power minus 3.
yeah, like we will be doing it, we will be integrating it simply, okay? Let's just write it first and then we'll do it. Okay. Now, how do we integrate? What is the simple integration? What is the integration of x? It is x squared by 2. So for
Squared
this, we
by
will
2.
have minus 2 plus 1, okay? And we need to divide it
Yes.
by new power. So this is
One
going
minus
to,
1.
yes. And on the other side, we will have minus x square by 2 plus c, right?
Yes.
And we will have finally minus 1 by y, because minus 2 plus 1 will give you minus 1. So y to the minus 1 can be written as 1 by y when it comes to the denominator, right? Right?
Yes.
Okay, and then we will have minus x square by 2 plus c, okay? And now I can take this minus to that side, so I will get 1 by y equals x square by 2 plus c, okay? We will not change this sign because whatever change we are making to our equation would be, we will get the constant accordingly, okay?
Yes.
Okay, so again I repeat. This was the question. We were asked to solve this, and this is somewhat different because we know that we had to do an extra step in order to integrate it correctly, right? So first we took
Yes.
dx to that side, and still we had y here and dy here. So we took y square here, okay? Now this is important. You said that we will have ln y square. No, remember, we do not have 2y in the numerator, okay? We do not have the derivative of denominator in numerator, so we cannot use this, okay?
Ln
This
y.
is a
Okay.
simple case. We can do it in the simplest way, okay? This is the simplest integration which you have studied, right?
Yes.
So just take minus 2 over here, and now we need to add it and we have to divide it by new power, okay? So we get y to the minus 2 plus 1 divided by minus 1, and now this basically is y to the minus 1, so I can write it as 1 by y, and at the same time we have to integrate this expression, so x becomes x to the 2 divided by 2 plus c, okay? And the best part about this constant is that whenever you have a constant, like we had this minus sign, I took minus sign from left hand side to right hand side. Okay, I changed this minus to plus because minus into minus is plus, but I did not change this sign by, because C is a constant. Whatever change we are making, once we have to find C, we will get correct C accordingly, right? So you don't make the sign changes with that. Constant always come with positive sign. Okay, and if it has
Okay.
negative
Oh,
sign, we will get that negative sign once we find C. Okay.
substitute the values. Okay.
Yes. Yes. Okay. So, like, have you understood this?
Yes, I have. It's fine.
Okay. Like, are you sure?
Yes.
Okay. Let's do the last example then. Okay. So, let's say that this time your differential equation is sorry, this dx by dt. There's a question, dx by dt equals minus 3x by 40 minus t. Okay. Now, how do we do it? We have to do it by taking dt to that side. So we will have dx equals minus 3x by 40 minus t dt. And then I need to I need to take this to this side because we have x here and we have dx here. Okay. So we need to do it correctly. So we will have dx 1 by minus 3x equals 1 by 40 minus t dt, right? Are you clear with this?
Yes.
And now we have to integrate it. Okay. So when we integrate it, we have to integrate both sides. What do we get? We can take this 1 by minus 3 outside and we have 1 by x dx equals 1 by 40 minus t dt integration. Okay. Now, how do we do it, Ranjani? How are we going to integrate this now? This side?
1 by x dx. So this will be ln x.
Very good. Very well done. So, this would come with ln x equals, and what would be the integral of this side?
You can just take the reciprocal of this. Reciprocal as in like, not reciprocal, 40 minus t to the power negative 1, and then just differentiate normally. I mean, integrate normally.
No, no, we can't do that.
Oh, even this you can take ln x because integral
Yes,
of one
derivative of,
differentiation of,
yes,
yeah,
yes, yes. So,
is
what is the
1.
derivative of
So,
minus t?
so can't you take 1 by 40 outside or?
No, look, I can't take 1 by 40 outside because like 1 by 40 is not being multiplied, okay? If it was being multiplied,
Okay,
yes, in that
only
case,
then you can.
yes, yes, yes. Okay, I can't do it this way because that is
So
mathematically incorrect,
ln
right?
40 minus t
Okay, but what is the derivative of this function?
minus 1.
Yes, so do we have minus 1 in numerator?
No, so you put minus, you divide it by minus 1.
Yes, so I will basically write minus outside, right? I need minus 1 outside, right? Thus, so I have it inside as well because this is minus t and the derivative of minus t is minus 1. Okay, now listen to me. You said that even we can do it with ln. Not even, we can only do it with ln. For expressions with power 1 and power 1, okay, for such expressions you can't do it this way, that you take it to the numerator, you do this, and you do this because you know what, x to the minus 1 plus 1, this way you will get rid of x. This would give you x to the 0, that is 1, right? Do you understand? In the last question we had 1 by y square and we had to integrate it. Okay, yes, for such questions when the power is greater than 1, we can take it to the numerator and then integrate it in the simple way, right? But for expressions with power 1, if you take it to the numerator, just like you said initially, let's do it that way. So if we do for this 1 integration of 40 minus t to the minus 1 dt. This is what you said, right?
Yes.
Okay. And now let's do it that way. So we have to add 1. We need to add 1 in the power, right? So what and divide it by new power. So can we divide it by 0? And can we afford getting a 0 here? Because if we get 0 in the power, this expression would become 1. And if we get 0 in the denominator, this expression would become infinity. So it is a rule, okay? You cannot take such expressions to the numerator and do it in simple way, which expressions have 1, okay? Because this one, when it will go to the numerator, it will become minus 1. And for integration, you have to add 1. So minus 1 plus 1 is 0. Anything to the 0 is 1, right?
Yes.
Have you understood it?
Yes.
Okay, so we are clear that the only method of integrating right hand side is to take natural log, okay, and nothing else. So this means that we need the derivative of denominator in numerator, so we need minus 1. For making it mathematically correct, I need to multiply minus 1 outside as well. Just so minus 1 into minus 1 is 1, okay?
Yes.
So this will give me 40 minus t plus c, right? And
Yes.
I can take this 3 to that side because I want in terms of x. Ln x equals, and this minus can be cancelled. So I will have 3 ln 40 minus t plus c. Ln x equals ln 40 minus t. Can I take this 3 to the power of this function?
Yes, you can.
You know this concept?
Yes.
Okay. And now I need x only. So what do? I will take e on both sides, right?
Yes. So you can x equals 40 minus t cube.
Yes. X equals 40 minus t cube plus what?
Plus t, right?
No, plus c.
Minus t cube. Yeah, plus c.
Yes, plus c. Why were you saying minus t cube?
Nothing.
Okay, so have you understood it?
Yes.
Are you sure? Any questions from this chapter? We're done with this chapter.
No, it's fine.
Okay. All right. No questions. Are you sure?
Yes.
Okay, then I'll clear this. And let's talk about, I'll stop the recording as well because I need to record it. For, yeah, okay, sorry. I need to record it separately. So I'll stop sharing.